My name is André. I am the founder of a startup called Encore, which I'm here to talk a bit about today. Long time Gopher, started programming in Go back in 1.0. At that point, I was at Spotify, so was doing a lot of backend development, distributed systems, and so on. And I built a lot of Spotify's internal infrastructure for Go. And when I'm not doing that, I am taking care of a little puppy called Salvador. He's incredibly cute and very, very playful. So we'll see if he interrupts this talk, but right now he's sleeping. And so I'm here to talk about distributed systems, which is what I do in my day job and have been doing for a long time. And maybe a better way to express them, a more natural way to express them, to try to get rid of some of the complexity surrounding that. And to maybe frame the problem a bit more, in my experience, when you're building a backend, like you have this idea in your head about what you're trying to do, and usually it's something simple. Like, oh, you're getting some data from an API and then processing it and then storing it in a database and then you're done. But there's incredible amounts of boilerplate that surrounds the core functionality that you're doing. That ends up being where you spend a lot of your time. And when you're building a distributed system, you're just not dealing with one part. You're actually dealing with hundreds or even thousands of moving parts that you're trying to get to work well with each other. At Spotify, we had several thousand backend services, and there were so many that we didn't actually know exactly how many there were, which sounds crazy, but is the truth. And even when you're a small team, the moving parts ends up being like you're just both writing your own parts, but you're also combining that with infrastructure in the cloud and different tools that you're connecting together and external APIs and so on. And the end result is an overwhelming amount of complexity, right? Like the applications we're building, they seem so simple to use, whether it's Spotify or Airbnb or Google, right? Like they feel super simple, but the complexity under the surface is just incredible. And that's a problem because it means that building that software is much slower than we would like because we're constantly struggling with all of this complexity. And so maybe to illustrate it a bit more, right? Like when you're building a backend, usually the way it works is you have some sort of front end that's communicating with it. And inside your backend, you're writing some business logic, you're talking to some external API, you're doing some processing, you're talking to another backend maybe, and then you're storing some data in a database, and then you're returning some data back to the front end. And if you just do this, and most backends are just variations on this idea, right? And if you do this over and over for 15 years, you end up building Spotify, pretty much. It's really, in concept, it's not that much more complicated. It's just a lot of work, right? But it seems really simple when you look at it this way. The reality is, even for something super simple, there's a lot more to it, right? So we're talking, you need a build system to actually build the code you're writing. You need a deployment system. Usually these days you use Kubernetes, and then you need to provision the database. You need secrets for connecting to the database, like a database password or an API key. You need to actually manage a database connection pool and servers and migrations and transport protocols and DNS. It's like an endless list of stuff. And all of this stuff on the right is actually not really about your application. Everybody who's building for the cloud have exactly the same problems, and they're doing all of this work the same way that you're doing that work. So it's not differentiated in any way. It's not unique to your backend. And what's more is there's nobody that can actually help you do this work because you are the only one who actually understands how your backend is supposed to work. So the only one who can actually do this is you. And that is a problem because it means that what seems really simple ends up being, months of work just to have something working in production when it should be days. And so a lot of this is about infrastructure. And so there is this concept called infrastructure as code, which is really about, instead of clicking around in the user interface, maybe we could just write some code to define the infrastructure that we need. And that gives us some, it makes it more reliable because you can check it into source control. It's more reproducible if you want to tear it down and create it from scratch, and so on. So here's, for example, an example. This is using Pulumi to define like a GCP network with a firewall and a compute instance. But when you do this, you're essentially just writing more code, right? Like, we're not doing less work. We just replaced clicking around in the UI with writing more code. And since they're different, we end up, over time, it's very common that they diverge, right? And what you write in your application might not match exactly the infrastructure code that you're writing, or the infrastructure as code part ends up going out of sync with your cloud infrastructure. And it ends up being very production centric, right? Like what we're looking at here, it's really only the configuration for production. If you want a test environment, it's going to look a bit different. For local development, this doesn't work at all, right? Your computer is not running in the cloud. It's on your computer. So it ends up being a bit of a letdown. Even though it has good ideas, it doesn't really solve the problem. And so what I realized is, if you look at, when you're writing a backend application, it's really about, in your head, you have this idea of how the application should work. So you have this, system diagram where you have relationships between services and how they interact and so on. And this is really what we're trying to do with our infrastructure. We're taking this idea and we're trying to translate that into actual infrastructure. So if I have this architecture diagram with four different services, one of which is a front end, and then 3 backend services. We have 3 different databases, one for each service. We have some events, which is like Google PubSub or whatever. It's pretty straightforward to go from this picture to the infrastructure that we want. Most people who are comfortable with the cloud could do this. It's pretty straightforward and obvious how you would translate this into cloud infrastructure. And the problem is, our tools don't understand this, right? Like, this picture is only in our heads. And what we would like is for our tools to achieve the same understanding, but they don't. And if they did have that understanding, then maybe they would be able to help us in a better way. So I had a bit of a crazy idea, right, a couple of years ago. And I thought, if we could teach our tools to understand what we're trying to do, then they could be much more helpful. And if they had really understood this picture of our systems, they could use that to, set up all the infrastructure and really help us to do what we're trying to do when we're building our backends. So that's what we built. The core idea behind all of this is what we call the Encore application graph. And it's essentially a way to write a backend, like a distributed system, in a way that we can build up this picture that we have in our heads. And by doing that, our tools can be much more helpful in, really helping us create and build our backends much, much faster than before. So I'm going to switch over to a quick live demo and show you what I mean by this, and then we'll get on with the rest of the presentation. There we go. So what we're looking at here is this is a very simple picture of our backend application. And right now, there's nothing in it. It's just a load balancer, which doesn't send data to anything. So what we want to do here is, and I'm going to zoom in a bit so we can see better. I'm going to try to replicate this picture that I just showed you with like an order management system and a payments gateway. So first thing we do is we create some a backend service just by creating a folder, and we're going to call this the order service. I'm going to make this on the side so we can see it while we do this. And so now I'm doing this with Encore's syntax. So with Encore, you define APIs by using this annotation, and you create a function. So here we're creating the order.create endpoint. And we'll just say that it returns an error, nothing else. And once we save, we can see that Encore updates its application model to see that, oh, now there is an order service here. And that's based on understanding that this is defining an API. And that means that this package is a microservice. And what we can then do is we can create another service. Let's call it the payment service. And in here, we'll do the same thing. I'll even copy paste this. Oh, instead of payment, we'll call it pay. And now you can see that we now have two services in our application model. Now this is called public, but we don't want the pay endpoint to be public. We actually want it to be private, because it's not going to be exposed in the load balancer. It's going to be called from the from the order service. So when I make it private, you can see that the load balancer is no longer connected to it. And if we go back here, this is just an example. So I'm just going to illustrate how this works. We can say payment.pay. We'll pass in the context, and so with Encore, when you have two different services, the way you do an API call between them is you import the other service like this, and then you call the function as if it is a regular function. And this is how Encore understands that we're actually doing an API call between services. So now when I save, you can see that the application model is updating its understanding, and now there's a relationship from order to payment, because Encore understands that the order service is actually doing API calls to the payment service. We can go even further, and we can create, let's say that in the payment database, in the payment service, sorry, we want to have a database where we keep track of all of the payments. So with Encore, you do that by creating a migrations folder. And payment. It's just an example, so I'm going to keep it simple. If we go back here, what we want to do here is we want to use Encore's SQL database package. We import that. We're going to execute a query. And now when I save, you can see that since we import the database and we do a database query, Encore updates its understanding of the payment service and understands that this payment service actually wants a relational database attached to it. And this is a very simple example, and it doesn't actually do very much, but it illustrates, how we can create this concept where you're just writing business logic and our tools understand how our distributed system should work. And this is really the core idea behind Encore, is do this, but take it much, much further so we can actually do real world applications in this way. And so the core idea behind all of this, right, is we want to be able to develop distributed systems. And the concepts that we want are things like services and API endpoints that I just showed you, doing API calls, parsing and analyzing request and response schemas and secrets and so on. And we also want on the infrastructure side to be able to understand things like the databases we have, the schemas, when we're using blob storage like S3 from AWS or Google Cloud Storage and so on, when we're using caching and distributed queues and PubSub, and so on and so on. And these are the sort of primitives that we really want in our, framework to be able to build distributed systems incredibly quickly. And this is what we're doing with Encore. We're taking all of these concepts and we're making them like providing a standard way of expressing that enables us to really understand what you're trying to do and help you do that quickly. And just to give you a quick idea of how this works is we have, in the same way that a compiler works, when you're compiling Go code, it takes the code and turns it into an abstract syntax tree, where the nodes in the tree are things like function literals and if statements and binary expressions and so on. And with that syntax tree, we can then do a bunch of compilation passes to turn that into machine code. And this is a very, very big simplification, but it explains the core idea. And the way Encore works is essentially the same thing, but where the syntax tree that we're creating are not function literals and binary expressions, but really distributed systems concepts. So like microservices and databases and endpoints and API calls and so on. And with that syntax tree, we can compile that into infrastructure and distributed systems solutions to things like setting up all the infrastructure, but we can also do a lot more. So we can generate code to reduce boilerplate. We can generate API documentation. We can even simplify debugging through distributed tracing and so on. And so this is really what Encore is all about. So now I'm going to show you a demo of the actual product. So the way Encore works, right, is we start with creating an application. And that application corresponds to our complete backend, right? It's not a microservice, it's everything. So we can say GoSG demo. We can choose a few different templates, but I'm going to choose the Trello clone just to give us something to work with. And let's open it up in our editor. Oops. And there we go. So with Encore, when you're, we're going to look into the code a bit, but to actually run an application, you just type Encore run. And the first time it takes a few seconds to do all the compilation and so on. And then you can see that it's registered all the endpoints. You can see the API paths for actually calling the API and so on. But it's quite hard to understand a backend by just looking at the code. So I'm going to, we've actually built a custom front end that connects directly to our backend just to explain a bit what's going on. So this is a Trello clone. I'm going to choose the local development. And now we're connected to my computer. So here you can create a board. You can create columns. You can create cards. You can drag them around. If we refresh, it's still there because it's all being stored in a database and so on. So this is a fully functioning Trello application. And if we go back here to our editor, we can see that what I just did, it made a bunch of API calls, right? And so now we're ready to look a bit at the code. And this is the same principle that we looked at earlier, right? Where we have our Encore APIs. Our APIs are just functions. Now we're taking in request and response parameters. And these are actually types where the fields are the fields in our API. And this is the response type. And inside here, to actually create a Trello board, it's very simple. We just insert it into the database. We get the ID back, and then we return the generated board. Down here, we can see a bit more complicated API, which is to actually retrieve information about the board. And here we can see that we're first querying the database for it, but then we're using an error group to do two things in parallel. So we're doing an API call to fetch all the columns, and we're doing an API call to a different microservice to fetch all of the cards. And then we wait for this to complete, and then we merge them together, and we return the board. And so this is a bit more complicated, but still, really simple. And when you're using Encore, you get this really powerful local development dashboard for making it easier and faster to build your application. And what this does is it enables us to do things like generate API documentation for you. So what we're looking at here is the generated API documentation for your backend. And here you can see all of the APIs that we have defined. We can take a look at the board.create API, which I showed you earlier, where we have things like the input is the name of the board, the response are a bunch of fields, board.get is the thing I just showed you. We can even call it directly from the documentation. So this is always up to date because it's based on parsing your business logic, but it's also interactive. So you can even call it here and see the response and so on. And if we go back here, here you can see on the right-hand side all of the requests that have been done. And with Encore, we even do this thing called distributed tracing, where when we run your application, we analyze and instrument your application with a bunch of debugging information. And it lets us do things like build this really powerful view where you can understand exactly what happened to your request. So what I just showed you here earlier is this this API where we're first doing a database query. And then in parallel, we're calling the list columns API and the car.list API. And if we go back here, we can see that this is exactly what happened. This is the board.get call. It made two API calls. And on the right-hand side, you can see that these two API calls were happening in parallel. So this is like a timeline view where you can see all the Go routines that were working to process this request. And the first thing that happened was a database query. As soon as it completed, we fired off two different Go routines. Those Go routines made a list columns call as well as a car.list call. And you can even see the request and the response data for each one. So this is super powerful for quickly finding bugs in your application and figuring out where the problem lies. You can even, for each event, you can even see where in the code base it happened. And then once you're happy with how things work, deploying to production is just as easy as git push Encore. And what this does is it pushes the code to our cloud platform, where we'll parse all the static analysis, we'll run the tests and the builds and so on. And once this is successful, then we'll actually set up all the infrastructure in the cloud. I haven't logged in. So we'll give this a minute to send the email. And if we go back here, it's all streaming to our terminal anyway, so we're not really missing anything. So once the test's complete, we'll set up all the infrastructure in the cloud, and then that's happening now. We're setting up all the infrastructure. We're actually deploying it. And once this is completed, everything will be live running in production. So I'll open take this, go back here. And there you can see. So once this completes, we'll have our production environment up and running. Here you can get, everything from metrics and logs and tracing. You get API documentation. You can browse the code if you'd like. And you can even deploy this to your own cloud. So instead of using Encore's cloud, you can just go and select the cloud that you want to deploy to, and then everything will work the same way, except it will deploy to your own cloud account. So you have full control of all the infrastructure. And Encore is just there to help you ship faster. And that's it. The benefit of this is almost no boilerplate. We can do a lot of crazy stuff to help you get your work done faster, from code generation to API documentation and tracing and so on. And all of this works everywhere, right? It works on your computer. It works in the cloud. It doesn't matter which cloud. It works in your test environment. It even works on each pull request. And that's really powerful, because it means that wherever you find any problems, Encore makes it super easy to fix them. And everything I just showed you is open source. Everything from the parser and the compiler and the command line and the framework and the API documentation, it's all there. And with that, thank you so much. If you want to check out Encore, either check out our repo or encore.dev, and happy to take any questions, of course.
First question, how would Encore work in a team setting? So I guess it's related to the second question. Would there be a need for the Encore parser running on each seat? Yeah.
So great question. So Encore is definitely built for teams, right? Like everybody who is using Encore are connected to the same cloud platform, which means that we can make it very, very powerful to actually collaborate between people. When you create a pull request, Encore is actually connected to your GitHub account. And in that, we actually create a dedicated test environment for each pull request. We can also do things like generate type-safe front ends for, if it's TypeScript or, any other language. We can generate a front-end client that connects directly to your backend. So there's even no boilerplate necessary for other developers too. So it's very much designed to be incredibly useful, not just to individual developers, but really whole teams.
Okay, thanks for that. Second question also, Sween. Do you have any bindings for other languages like Java or Python?
No, it's really, all of what I showed you is super Go specific, right? Like everything from the distributed tracing to how we're expressing, distributed systems concepts to doing like runtime instrumentation. We could certainly, explore adding other languages, but right now we're focused on providing, a 10x improvement to productivity. And to do that, we really want to get super specific and deep into the language. So we're just focusing on Go for the backend experience, but we'll support lots of languages for, integrating with when you want to integrate your Encore backend with other systems. So everything from JavaScript to Python and Java and so on. So that's definitely the plan. But in terms of how you write your backend logic, it's Go specific.
Okay. Good to know that. All right, 2 more questions. One from Donaldson. The advantage of combining infrastructure as code with business logic. Usually we separate them. Yeah, what's your viewpoint on this?
We usually do them separately, but in my opinion, that's only because our tools don't actually make it very easy. In practice, they are incredibly coupled. When you're writing your business logic, you do that based on an understanding of how things are supposed to work in production. And so there is always this coupling between your business logic and your infrastructure. With Encore, when you're expressing, doing a database query, you're doing it at a higher abstraction level where you're not saying, connect to this database running in the cloud. You're saying there should be a database connected to this service. And Encore takes care to actually connect them together when it starts your application. So when you're running it on your computer, the database is running on your computer too. When you're doing it in a test environment, the database is like a very small test database. And when you're running it in production, it's a dedicated managed database that has daily backups and read replicas and so on. So it's not coupled. It's just helping you by understanding what you're trying to do and making that easier.
Okay, got it. Right. Another question, Saga. Can we use gRPC for communication between the services instead of REST? Yeah,
it's a great question. Right now, it's all HTTP. When you're defining multiple services within Encore, you don't even have to think about the transport protocol. You just do it in terms of functions. And what's really nice about that, right, is I guess I didn't show this, but since it's all functions, you actually get, code completion for your API calls, right? So your editor will actually autocomplete and tell you when you're doing something wrong with your API calls. Maybe I should actually show this because it's super powerful. We go back here. Yeah, so here we can see that this is an API call to car.list. But if I were to write this from scratch, I would do card.list. And you see you get compile time autocompletion for all of this. Even do it for the request parameters. So here you can see that this takes a board ID. And if you even get this wrong, say you thought it was named something like this, the compiler will actually tell you like you're passing in the wrong data to your API. And this is super powerful because normally when you're doing API calls between services, you're never entirely sure that you're doing the right thing, or that you're passing in, if you're passing in a string instead of an integer, the compiler will also tell you. And if you're doing a refactoring, you go back here and you want to change the name of this to something else. And the compiler will actually, refactor this for you. And so that's really the benefit of using Encore between services, is it becomes much more type safe than the alternative. And when you then save, it library loads and so on. So the transport protocol between services doesn't really matter because it's more in terms of functions and data structures. Over time, we will add support for gRPC. But the real goal is to not think about that so much and more think about your business logic and think at a higher abstraction level.
Okay. Maybe we can have one last question is from Donaldson. All I see is backend code. What about front-end coding?
Yeah, so Encore is very much a backend framework. It's everything is designed for solving backend challenges. So defining APIs, building backend services, making API calls between them. We do make it easier to integrate it with your front end. So, for example, if we go back here, and so a common challenge you have as a front-end developer is actually to actually call the backend API. So with Encore, you can generate a type-safe front-end client just using Encore Gen Client. And this will be fully type-safe, fully documented, and just ready to use with all the types you need. So that means that as a front-end developer, all you need to do is instantiate this, specify the environment, and then you can call the API like this. So we do make it easier for front-end developers too, but it's very much designed to solve backend challenges, because that's where there has been a lot of innovation on the front-end side, and there has been not so much innovation on making it easier to build backends. So that's what we're focusing on. And then there are lots of other great tools for making front-end development more productive.